lot of influencers on Twitter just say it is going to end software engineers. AI is going to eliminate them all. And that's something that I disagree with. And that's largely because, I guess, as many people have noticed, it's the coding part that AI is doing well, and not necessarily the engineering.
Hello, welcome to another edition of Peer Review. Today we have Sergey Tselovalnikov, a staff software engineer from Canva. Sergey previously worked at JetBrains. One of the reasons I'm excited to have him on is he's written some really amazing blog posts recently about the impact of LLMs on software engineers, and also kind of coined the term vibe engineering and how does that compare to vibe coding. I thought these are really topics that our listeners care a lot about, and they've elicited a lot of discussion on forums like Hacker News. So welcome, Sergey.
Hi, Amar. Nice to meet you.
So let's start off by talking a little bit about vibe engineering. So you wrote a post, there's no such thing as vibe engineering, and it sparked a lot of conversation. The way I kind of read it was, vibe coding, you said, is, hey, it's code that you're just writing by the prompt and the LLM is really writing the code. The developer's not writing the actual code. Of course, that's vibe coding. But then vibe engineering is really about, well, how do you build a system that integrates code for multiple developers, code over time, scales, is reliable, stands the test of time, and becomes, a larger code base that you're kind of integrating vibe coding into, or any kind of code into. I guess first, what inspired you to write that?
Yeah, I guess it's mainly the hype, or rather the sheer amount of hype on the internet about vibe coding. And since Andrei Karpathy coined this term on Twitter, it's just exploded. You can see it everywhere. One of the most popular takes on this, I'd say, a lot of influencers on Twitter just say it is going to end software engineers. AI is going to eliminate them all. And that's something that I disagree with. And that's largely because, I guess, as many people have noticed, it's the coding part that AI is doing well, and not necessarily the engineering.
In your mind, or you talk a lot about this, of course, in the blog post, what's the difference between coding and engineering?
Yeah, and that's something that I feel a lot of people miss in that case, even though it might seem obvious, like if I explain it in details, but coding is point in time. Effectively, it's creating the code. It's the process of producing the code. However, the engineering is, by contrast, is coding done, let's say, over time, or rather you engineer a system that's you designed to withstand the changing conditions of the world within the next, N years, depending on the product. And this is very different process compared to just writing code, I'd say. And AI is doing the coding. It's yet to do engineering.
So talk a little bit, so when you say it's, developing that product over time, integrating that software over time. So what are some of the types of things that you think are critical in engineering that maybe don't matter in coding?
Yeah, I guess it's all about the change, and systems change over time. And you, as an engineer, design a system that can change within the next N years. And let's say, just for the sake of this exercise, that you're designing a system that's meant to serve a certain type of load within the next 5 years and be deployed somewhere and serve real user traffic. And in that case, you, of course, anticipate some load and you kind of anticipate the requirements, but you don't know for sure what they are going to be.
Right.
And in that case, your role as an engineer is to anticipate those, look maybe 5 years ahead and design a system that is not necessarily going to live the next 5 years without a change, because that's almost never happens. Right. The systems is going to evolve and change, and you as an engineer make it possible. You write a code in a way that can, let's say, sustain that stream of changes and still be evolvable, because any system ultimately dies when it's too hard to change that system.
Got it. So let's talk a little bit about a lot of, engineering practices over the years, I'd say, have been trying to shift, things to earlier stages of development, shift left, right, is kind of been the motto for the last 15 years. How do you see vibe coding kind of fitting into this? And what do you think? How does that affect things?
Yeah, and that's a very interesting point that is almost unrelated to the point before. However, it's still deeply connected. And if we treat vibe coding as, let's say, a practice of you as a vibe coder, creating a system via prompts only without the deep understanding of the code underneath, then you're effectively being a project manager for the project. You design the system through prompts. You tell the AI what to do, and then you evaluate the results by looking at the final product. At least it's how the vibe coding was defined originally on Twitter. I'm not sure if that's what everybody implies when they say vibe coding, but let's, for the sake of this discussion, specifically refer to vibe coding as this kind of process. And historically, we've always been trying to shift things left to as early as possible to catch all of the bugs, prevent security issues, to fix things early. And with vibe coding, we shifted to the right. And I guess the best example to this is you're probably familiar with the concept of black box testing and white box testing, where when you test something as a white box, you are aware of all of the conditions. Maybe you are aware of the internal implementation of the system. You can understand all of the edge cases in each case, and you can, knowing that, you test those conditions. However, if you are vibe coding a system, you're not aware of the internal implementation. You just simply cannot do white box testing. You can only do black box testing. And even though black box testing is good, after white box testing has been done, it's practically impossible to test the system fully just with the black box testing. And that applies to not only code bugs and issues, but also to security issues. It's almost nobody hires, let's say, a red team before hiring a blue team first. Almost nobody does black box security testing before actually looking at the system and trying to anticipate or figure out where the holes might be.
So it sounds like you're kind of saying, hey, these engineering practices, I mean, whether you do them early or late, like they're still super critical, probably preferably doing it early. It's better to probably design a system first.
I definitely,
it, but in any case,
I definitely agree. And not knowing the system, not applying them early and shifting them to the far right of the development process makes them much more costly to fix.
Yeah. So you talk a little bit in your post about kind of, you think engineers might become a mix of architects and platform engineers. Maybe you could just talk a little bit about how you came to that conclusion and expand on that.
We as will apply some sort of vibe coding in order to design a system that's effectively consists of a number of blocks that are built with vibe coding. And then we as engineers connect them together in order to produce a reliable system out of unreliable parts. And in that case, if we system and we were to try to design it, we would prop what an LLM AI can do in those environments. We would try to restrict a possibility of introducing a security bug by design. And right now, when you vibe code a system, you use the same runtime, you use the same tools that are available to you as an engineer. While if I were to try to design a safer system for an LLM to run it, it would be a heavily restricted sandbox. And I'm not saying that you can use something like a DSL on top of the existing tools. I'm not sure if you've played around with Supabase, where they could only call a very limited set of APIs, and we would restrict the vibe-coded parts to only those parts of the system, then maybe we'd be able to design such a system. And here where the platform engineering part comes in, because somebody has to build those DSLs. Somebody has to design such a system, which is effectively a sandbox. And that would be the platform engineering part. However, another role is to design a broader system by applying the same practices as the modern, let's say, architects, how you can call them, or staff engineers or other people, how they design the systems out of different services that are, let's say, are available to you. And in the same way, you would still need somebody who can design a system out of those blocks, I'd say. So those are the two parts that I mentioned, the platform part and the architect part. But again, that is just me guessing. Nobody knows what's going to happen in a few years. So
Yeah, I mean, nobody knows what's going to happen. That's what I think makes it kind of interesting and exciting. Let's talk about, you had another blog post, which I thought was really great, which was the LLM curve of impact on software engineers. And you talked a little bit about how maybe junior engineers are really able to use LLMs a lot, and maybe mid seniority and senior engineers are actually getting less value because they really understand their code base well and they're trying to do more complicated things. And then you said, hey, staff engineers, I guess like yourself, are getting a lot of value out of LLMs because you're doing a lot of experimentation and trying things out, prototyping, etc. And I think, again, that got a lot of conversation on Hacker News. I guess one of the things I was kind of curious about is that some people kind of said, well, I think the dimensions might not be seniority. They might be like, how well you know the code base, and are you doing experimentation, things like that. I mean, what's kind of your thought? As you kind of put this out there, and I'm sure got a lot of feedback, adjustments you would make or new thoughts you had?
I would agree that the mapping is very rough. It's not horizontally applicable everywhere. That's for sure. However, one part is, I think, I would not change at all. And that's the danger to junior engineers.
Talk a little bit about that.
What I meant by that, imagine you're a junior engineer, maybe you left uni, joined a company, you are in an unfamiliar code base, and maybe you're using unfamiliar frameworks, and you're not very productive, like, realistically. But now suddenly you got a coding assistant, you've got some LLM that you can call, maybe you've got a GitHub Copilot or some JetBrains' Juni, some agents running in your IDE and helping you get job done. And suddenly you're just applying those suggestions and things kind of work. You make a lot of progress. However, if you only apply those suggestions without deep understanding of what you are doing and why you are doing the changes, what those changes actually mean, what the consequences of those changes are, if you are not trying to understand those, it's quite dangerous to you as a junior engineer because you won't be able to progress much further.
Really learning and understanding what you're doing. I think there's a lot in that, for junior engineers and in many professions, like getting that mentorship, doing the work, being wrong. My kids, for example, they do work on some math, and when they are struggling with a problem, their first thought is like, oh, if I'm not around or whatever, I'm just going to go to ChatGPT and ask it, And I kind of really was very concerned about this. I was like, you have to struggle, you have to try. So I said, you have to try for 20 minutes on a problem before you can go ask ChatGPT to help you, because it's inevitably gives you the answer. You read it, you think, oh, I know it, but you don't really know it. You just kind of scanned it through. So I think absolutely see, what you're talking about. And
yeah, it's almost like universities will have to introduce a course at some point, how to use those assistants effectively to learn and progress. And I guess what I might change my mind on sooner rather than later, maybe, or rather what I don't have a lot of confidence in, is the fact that senior engineers are not benefiting a lot, because that is the state of the things today. Tomorrow, that might change. The tools will get better, and senior engineers would get even more benefits compared to junior engineers, because the tools will simply make them even more efficient, and it won't be faster to do things by hand anymore, even in large code bases.
Yeah, I mean, I think where a lot of the models and tools kind of fall down today is deeply understanding the code base in a larger code base, or even a medium-sized code base, and what are the design patterns, what are the approaches you've taken, and I think reflecting that in the vibe coding that's happening, right?
Yeah, for sure.
So it's early to maybe think about this, but how do you think kind of AI and automation are reshaping like the engineering culture? Like do you think that they're changing how people are going about their roles today?
It is a good question. I haven't seen a huge change in the roles of people specifically, way too much. However, that might happen. Certain things might change again. I haven't really seen some drastic changes, let's say, for what junior engineers were doing before versus now, on medium level engineers before versus now, staff and principal engineers before versus now. Things haven't changed on this front much from what I could see. I think what has really changed is how much a single engineer can build without a big team of people. And what I mean by that, it's what has changed is what you, as a single mind, can do either in your free time or maybe as a small startup or maybe as a small company. That has changed a lot.
So people are getting more productive and you'll be able to get more done.
Yeah, for sure. And that the same applies to larger companies as well. People are getting more productive. However, their roles ultimately haven't changed that much, I'd say, at least from what I have seen so far.
Yeah. So if there was like one mindset shift you kind of hope engineering leaders would take away from this conversation about the impact of LLMs on different kinds of engineers, vibe coding, vibe engineering, what would you say? What advice would you give?
Be pragmatic. And what I mean by that, it's if you open Twitter and see the feed, if you open LinkedIn and see the feed, you would see a lot of hype. That hype would be coming from different places, from both sides, actually, from people who believe in AI, and they might genuinely believe that this is going to be changing the world tomorrow, that you can do a lot more today compared to before, as well as the other side, where people just say nothing is going to change, it's all a toy, and people have different experiences. And you have to be pragmatic and find where your situation is in between those 2 points, because depending on your circumstances, depending on your code base, depending on what you do, your experience might be anywhere on this range. So you have to try yourself. You have to apply all of those tools to what you are doing and possibly realize what that means for you. Not just blindly trust the hype on the internet or the anti-hype. And what that means is trying tooling, trying what you can do, trying how far you can push things. But at the same time, you shouldn't play with the toy examples and just toy projects on the internet, because everybody knows we can open V0 today, type a few sentences and get a pretty nicely looking landing page. But if you try the same approach with a very complex app, with a code base, with many users, with high load, that might not work as well. So you kind of like have to try your use case and see how that changes. What do you do?
Great. Well, thank you so much. It was really great chatting with you, Sergey, and I look forward to staying in touch on this. Thanks.
Yeah. Thank you for inviting, Amar. Thank you.
Yeah.